me tell you that the next week task is to come up with a reverse engineering project. This project is it will talk about that how to disassemble a product and to understand how many components are there in that product and what are the functions of those components. And your job is to follow this rubric, and this 10 points come from the showing me the slide of the black box. And the submission date for this project is 2 to 3 weeks time. When I say 2 to 3 weeks means like first I will give you 2 weeks time, then if you cannot complete in 2 weeks time, you will still have one more week, which is the final week extension, and then you can submit that mini project. This will be were conducted in the form of a team. So you are working in probably 7 to 8 teams, and then you will be dissecting or disassembling the project. For example, the first important thing is the black box. You will have 10 points coming from the black box. What it means by that, that you have a product and you draw a box and you don't know what is inside the box. The signal goes here, and where does it go? There, and then starts work. But first of all, the inputs are written on the left hand side of the black box. For example, this radio, the black box, the inputs is you have a power supply going inside like 110 volts, and then you have a knob for radio frequency signals and knob for user choices, volumes, and frequencies. And once you on the other side, these are all the outputs. And the outputs here, you see the heat generates because there is some capacitors or resistors which get hot after some time, and noise is there, and sound, it brings sound to you which you enjoy the music or some other speeches or news. So and then you can see the status of your volumes and frequency. This is the simplest black box. Now I want to show you that if you go let me show you. Yes, over here uh, I want to show you an example of a black box of a hedge trimmer. So let me show you. Yes, this is a hedge trimmer, which is a lawnmower or the landscaping um instrument or device, and the power 1 to 110 volts. This is a electrically operated hedge trimmer, and it cuts the bushes to specific like lengths depending upon your requirement. So power is going inside the hedge trimmer. There is a safety off switch and toggle on off switch. When you turn the safety off, then you have turn on and off button. To have the any child or any person who is not aware of this, so he or she should not be toggling it on when there is the blade starts moving. On the other side, the output, the blades, they shear and they cut the shrubs, and then it generates noise, of course, heat loss and vibration. So I believe you have understood these two examples which I explained to you. So now suppose you have certain products. For example, I tell you, you have a like a carburetor. Everybody likes to ride the motorcycle, dirt bike, lawnmower, these kind of things. The gas engines, they have a carburetor. So you will see. I'm giving you some of the topics, and you can or you cannot. It's up to you. You have freedom to select your own product, which you will be able to disassemble. I'm just giving you some example in the past. So nerf gun, impact drive, drill machine, inkjet printer, hard disk, old design, fishing reel, and so on. You can also Blender. Yeah, there was in the past, and people have also used Blender to disassemble. And you must select such a product which has at least like a 10 to more than 10 components. At least more than 10 components. So this is a requirement. So and then you should see it should be more inclined towards mechanical engineer. So I would not prefer like if you are like yesterday, the day before. Oh, sorry, yesterday I was teaching the same class. Students they brought an idea to disassemble a keyboard. I thought this is not purely mechanical engineering. So I would say you can select such a product which has more mechanical components like links, like gears or motor. Subsystem is also a motor. So mechanically inclined device. And all of these are mechanically inclined devices so you can think about. Now you will have an opportunity to share with me at least two products next week when we meet, and I will discuss with you, and we will come up with a design, one product which you can start disassembling in 2 to 3 weeks time. So the first thing is the black box. Okay, and the purpose for this project is to understand what is inside the product and how does it perform, how is it made up of, and why is it made up of this way. For example, these blades, they are made up of cast steel, and they are very hard, hard enough to cut the shrubberies or cut the bushes. So it is not required to cut the wirings. So that's why it has a different material. For wiring, we need to have a further a high carbon steel, so which can cut more stronger material. So let me show you the rubric. Have you understood the first rubric? And the next rubric is the glass box. So let me show you another glass box here. I want to, before I show you a glass box, let's do one more here. One more here is the black box of a screwdriver. By the way, I have uploaded these slides on the D12 already. So let's see what is the black box of this screwdriver. I'm just copying and pasting from the slides, just show you how it looks like. So if you show me this black box, like powers goes, ins, on off, safety switch, power or manual switch, it is similar to the hedge trimmer. And we don't know what is inside the screwdriver, battery power screwdriver. We don't know what is inside. Okay, guys, but it generate noise. It has screwdriver rotation. You see, this screwdriver starts rotating when you turn on off switch, and it has over here after the motor, it has power transmission, and vibration generates, heat generates. So let me tell you, the glass box. The next thing is the rubric says the glass box. It's a activity flow diagram, like uh, like where does the signal go from first component to the next component or part of the product. Sorry. Now it's an activity. Let me show you the flow diagram of screwdriver. This same screwdriver, let me tell you, the battery, the signal, power signal, when you turn on, the signal goes into the motor. So, and then the motor starts rotating. When the rotation happens, the gear starts rotating, and the gears in turn, they have the transmission to reduce the motor speed to a certain value, and it starts rotating the bit. So this is the flow. So the next rubric is the glass box. 10 points I will give you if you show me the glass box. This is a glass box of an inkjet printer, just to give you an example, but let me show you the glass box of a screwdriver. Okay, this is the glass box, means the signal, the flow diagram of a signal. When you turn the first component on, what happens to the signal? Where does it go? When you turn it the switch on, the power goes into the through the switch, and it turns the motor first. And when the motor rotates, transmission reduces the speed of the motor to the desired speed of the screwdriver bit. So this is the glass box. Have you understood the glass box? Okay, that's good. And now let's talk about this third rubric. And before I talk about the third rubric, which is a few questions, 30 points, which is a large piece of the 100%, 100 points, what it means, how was it made, why it was made this way, design issues, the material it is made up of, complexity and cost. These are 7 questions, but you should at least select 4 to 7 questions for each component. So when you are working in a team of 4 or 5, you will delegate the task like, okay, this subsystem, you are going to write down these 7 questions, or at least 5 questions out of these 7 questions. If you think these are applicable, you can find answers to them. So let me show you. Let me show you when you dissect. Let me show you over here a diagram here for the screwdriver. So this is how I want to see in your PowerPoint slide, that everything after you disassemble, you take a picture and zoom out and tell me, Professor, these are the parts. Like this is the housing, this is the motor, and this is the planetary gear system, and this is the housing for the screwdriver and planetary gear system, and this screwdriver bit. You see, everything is, and this is the housing for the battery, and everything is clearly explained here. So I want to see this disassembled product. And then you will talk about, suppose, motor. You will answer these 7 or maybe 5 to 7 questions, depends if you can find out more answers, and then you will get 30 points out of these 7 questions. You will select some of the components and answer yourself, how was it made? For example, I select the housing. This housing is made up of plastic injection molding. And why is it made up this way? Why this material has been selected? It is inexpensive material. It is easily available. Plastic is very inexpensive and very insulated. The electricity does not go through the plastic, and it is not even easy to break. Some plastics are very strong but durable, And similarly, you will ask your question, some more question I've written down. Why is it made this way? Design issue, any design issue, like is it ergonomically good housing, like you can hold the screwdriver, ergonomic issues. Ergonomic is a very major subject that it makes the productivity increased if your worker is ergonomically happy. The worker relationship, if they are comfortable working in that environment, like using the tools required to generate the production, so you can enhance the productivity. And even in 1 hour the worker will be probably making 10 parts extra as compared to the other, where the work and worker relationship is not is not conducive. So you can see that ergonomics is a very important part of the design product. Did I explain you these 30 points? And now comes the next rubric, the patent info. The patent is important. Like if you select, suppose, carburetor you have selected as your mini project, and then you will find the carburetor, google it. You see in the market, in the internet, you will see some patents already there, related, closely related to your carburetor, but some companies they don't want to disclose their patent info. So you can, it's okay. Well, you don't have to be very precise to be exactly for your product. You can just give me an idea, professor, this is very much related to the device which I'm going to dissect. So this is the patent. 5 points come from the patent info, and then three reviews. So let me show you. You can find some reviews. For example, screwdriver, you can find some reviews online, or you give me your own reviews. Professor, I have used this is very user friendly, but there are certain cons, that the battery drains very fast, and is although this is inexpensive, which is the pros, but the quality is not that good. I sometimes I cannot open the screws and it stuck. So these kind of things you have to explain in your reviews. But if you don't find your reviews, you can find from Amazon or some other online resources, and at least three reviews you should give me about this same product. And then comes the uh, motion types, and these are the motions. For example, let me show you. Let me show you one slide here. Rigid body. This is a page from a book of little bit higher classes, but we are going to see in this class that, for example, uh, if you have a part which is like a having a piston, a crankshaft, and every rigid body performs certain movement, and there are two types of motions. Rigid body performs two types of motion. One is the translation, one is the rotational. And you might be asking, professor, this is also curved, but even this is curved, we still consider the curve as a curvilinear translation. Both are translation. One is a rectilinear, means the lines of the 2 points inside the rigid body, they remain parallel to each other when the body moves from one position to another position. When the lines they follow a curve, when the body moves from position one to, then it's a curvilinear motion. When the body rotates around the axis of its own, then it performs pure rotation. Even if you change the axis to not passing through the center of gravity, then this is not a pure rotation. This has certain uh, rectilinear motion plus certain rotation. So it's a combination of a linear and So the fourth motion is the combination of the any of the previous three types or two types of rectilinear, curvilinear, or rotational. For example, a frisbee. A frisbee, when you throw it in the air, then it performs a rotation about its own axis, like the pure rotation, and then also it has a curvilinear path, and this kind of motion is known as the general plane motion. So what I'm saying here in the rubric, I'm mentioning, suppose there is a nerf gun. In the nerf gun, you are actually locating some gears. So if I ask you, what type of motion does this gear perform? You will tell me, Professor, this is a pure rotation. The gears rotate about their mass center, and it's a pure shape center, pure rotation. And if I ask you, what type of the motion, this linkage, for example, this connecting rod here, yeah, this is the connecting rod. This connecting rod is performing rectilinear motion. This end is rectilinearly moving, and this end is moving in a circular fashion. So this is a curvilinear motion. This is known as a general plane motion, combination of a straight line, one end, and the circular line on the other. Have you understood? Can you explain this in your project, that what type of the motion each component is performing? If it is a moving component, if it is a stationary component, then you don't have to answer this question. You can just tell me, Professor, this is not moving at all. You see, so you will just focus on these rigid body, the moving parts. You will explain this rubric. 10 points come from there, and then comes 20 points, bill of material. What it means by that? What, like if there's a drone like over here, you have to show me at least the parts names, call out the names of the components and their market value, cost estimate. This is how you will find out the complete product. If you call out, suppose, 10, 12 components, then you can make the whole product, but if you purchase those components by assembling them together. So the bill of material is very important. 20 points come from this project. If you show me this slide, and this is a very good slide for you to understand. Although not every column is required, but at least I want you to show me the name of the part, and the how many items, and what is the cost per item, and what is the total cost. This is just the estimated value. It's not to be very precise. And then 10%, 10 points come from attendance, means like you are present throughout the semester and the project's day, you will be given 10 points. So this is all. So next week when you come up with two design ideas which you want to dissect or disassemble and get the professor's approval. So with that, this is our major important thing which I want to discuss with you. Thank you. I'll see you next week.